Alright, so we're going to be doing homework 9 now. And homework 9 is going to be introducing dynamic memory allocation. And one of the new things is this malloc function, which stands for memory allocation. And so if you look at this header file of this homework, you might notice where we usually would just have static arrays in homework 7, we've replaced them with pointers. Right? And so, for example, this name in homework 7 would probably look something like this. Instead of having a pointer, you have a static array of maybe 30 characters. If you actually draw out the struct, let's say this is our user struct. A portion of it would be our name array. Let's say this is our name array. And then the letters, each letter would physically just be directly contained within the struct. So all 30 of these letters would actually be within the actual struct. And these static arrays have problems, right? So what if your user's name is 50 characters long? That's not going to be able to fit into the indices of this array. And what if the user's name is only like 5 characters long? Well, then you're kind of wasting some space, right? There's some problems with statically defined arrays. And so our solution is, instead of just defining a fixed amount of spots within our actual struct, we're going to use a layer of indirection. And we're going to replace this array with a pointer. Okay. Now we have our name. It's just going to be one pointer. And it's usually 8 bytes, because nowadays our computers are 64-bit. So pointers tend to be 8 bytes. And what we're going to do is, we're going to calculate how long the name exactly needs to be. And then we can use this malloc function, which will make a perfectly sized block on the heap that'll fit all the letters of our name. So if our name is 50 characters long, we can just call the malloc 51. For the null terminator, we have to add 1. And that's going to give us a beautiful block in the heap. That's exactly the size we need. Okay. And we can kind of tie it back to the struct by just setting this name to point to that block in the heap. Right. And what if our name, instead of 51 characters, is 7 characters? Well, if we call malloc 7, we're going to get a very small block in the heap. But it's just enough to fit our name. It has all these indices. We can set the letters in the heap, in this heap block, probably using stir copy, and then make our name point to that block. You can see this pointer really allows us to pick the perfect size for every user. And now we're able to accommodate the names of anyone, even if their name is 10,000 letters long. And we can just call malloc 10,000, which will dynamically give us a really big, really big block in the heap. And we can just make this humble 8-byte pointer point to that 10,000 byte block on the heap. So that's what we're going to be doing now. Alright, so I did a little bit of diagramming off camera. And so this is roughly how a struct user would look like. And it's interesting because it has a union in it. The union is strange in where the elements of it, so the student and the instructor elements, they're actually going to be overlapping a little bit. And they basically start the same memory address right here. And so there's going to be a little bit of overlap, a little bit of sharing between the instructor and student. Alright, so now let's get to it. And now I'm actually going to be doing the whole function for y'all, but I'm going to be leaving out the error handling. And so sometimes malloc can fail, and it'll return a null. So I'll let you guys handle all that annoying stuff. I'm just going to do the heart of the code. So first things first is they want us to make a user on the heap, I believe. They want to allocate memory for a user on the heap. And so we can use that with the malloc function. And all malloc does is take in a number of bytes. And so it looks like in this example I physically did the math out by hand, and I figured out that this user would probably take 24 bytes. Although, if I just put a 24 here, this code's going to be terrible. It's going to barely work on other systems. Like, what if you have a different, what if you have a system where your pointers are 4 bytes instead of 8 bytes? So, C has this really nice function called size of that kind of do all this math I just did out for me. So I can just pass in size of user, and it'll come up as 24 if I'm right, and in different systems it'll come up with different numbers. So this makes it really cross-compatible. And so what this malloc is going to return is it's going to return a pointer to that block on the heap, right? So I'm just going to grab that pointer and put it into a variable. Let's go user, malloc size user. Alright, so we can assume that now I have this 24 byte block in the heap. Now all we gotta do is start filling it in with values. Right now it's all garbage data. The first thing we do is our name. But what we have to do is our name is a pointer as well. It's not an array like homework 7 where we can just fill in character by character. And the expectation is that some people's names might be 20 characters, some might be 50 characters. So our name is another thing we have to dynamically allocate. And so, here. What we're also going to do is we want to make this also allocated in the heap. And we want this to be a pointer to a block on the heap that's just the perfect size to fit the whole name. Okay. And so maybe your name could be like MAX or something. And then null terminator. You can do that by new user dot name or arrow name. It's because we got to dereference the pointer to get the actual name. Equals malloc. I'm gonna do strlen. Strlen name and +1 for the null terminator here. And what this does is it mallocs strlen name +1 bytes. And it'll give you that a block on the heap with that exact size, basically. And just as a good habit, and we can get away with it because characters are guaranteed to be 1 byte, but it's always a good idea to do times size of car. Because if you're not working with characters and working like an array of like doubles or ints, you're gonna have to do this to make sure you're allocating enough memory. Right, because malloc will only take in a number of bytes, not the number of elements. Okay. So anyway, now we have to just initialize a name with values. So far we don't have the MAX part in, we just have the block. And so let's do that. We can just do new user. New stir copy, I believe. New user name, that's the destination, and the source comes to this parameter. And that should be set. Should copy it, and now we'll get our MAX on heap. Great. Now to set the type, kind of just do the same thing. There's nothing fancy about type. You can just basically set new user.type equals the type given in. That's going to take whatever this type parameter is and just place it as use type. Kind of like that. Great. And we also got to set the user data, and we're going to follow a similar process. So new user data equals data. That's going to take in this data and just place it right there. There's a caveat with our data. Okay. And the bane of doing this shallow copying is going to be your pointers. So you can imagine data as like a 12-byte block they passed in. This parameter, you can imagine it as a block just like this one. What if it was meant to be a student? In that case, it's going to have a grades pointer. It's going to be pointing to some grades, like maybe 90 80.0, 85.0, 70.3 or something, a bunch of doubles. And if we just try to copy all the bytes over, this is our new user. If it's a student, it's going to be pointing to that same array, because we basically copied the pointer over as well. But that's not a deep copy, right? Instead, you want to make a deep copy. So there's a caveat. So if it's a student, if type equals student, we're gonna have to do some special some special handling here. And in order to make a deep copy, the first step is we're gonna need to make a new block in the heap that's the same size as this grades array. Okay. Then we're gonna need to make this point to that new one instead of the shallow one. And then we need to copy these values over. 5.0, 70.3. Right, so the first step was, you guys remember, I make this block and then change the shallow pointer to this deep pointer basically. So we go new user at data. We're assuming it's a student. Then we'll look at the grades pointer. We're going to set that equal to malloc. And so how many bytes is this array of doubles? Well, it's going to be the number of elements in the array times the size of one double. That's how many bytes it's going to be. So what we're going to do is, I think the number of elements is going to be this num classes variable. So now data, num classes times size of double. Okay, that's the first two steps down. But now we actually have to fill it in with values. We got to copy it over now. I think there's a special function called memcopy. It's a very general purpose function. Memcopy, take a destination, which is new user data.student, grades, and then we're going to fill that in with data.student.grades. And then how many bytes to copy over? It's going to be the same as this. Just basically everything. Oops, gonna get a long line now. Hopefully you guys can still read that. Great. And I think that is it. That's the last step. So now we'll have a deep copy, basically 90.0, 85.0, and then 70.3. And I believe that's it. We've copied the whole user. And now we can just return the new user. So what if it's an instructor? Well, then the assumption is that the data we're given is the data for an instructor. And so when we just do this shallow copying, it's not even shallow because we're just straight up copying the primitives over. Now what I've left out is, let's say again, is that malloc can fail. So you guys have to make sure you're checking every time if malloc fails, and you're going to have to do some edge case handling. So there's one caveat with freeing that I think is important enough to bring up here, is that if your malloc fails, you're going to need to free everything you've previously malloced, okay? And you have to do it in a certain order, okay? You got to do it from inside out. So if I call malloc data.student.numClasses times size of double, and this fails, so basically I don't get the steep copy over here, I need to free everything I've done before. And so I've malloced two things before. I've basically malloced this 24 byte block in the heap, and then I've also malloced this looks like 4 byte block in this example for the name max, this 4 byte block. So I have to free it inside out. If I free new user first, I actually will lose access to this malloc block in the heap, and that's called a memory leak, because this max block is still on the heap, and there's no way to free it anymore because you already got rid of your new user. So you're going to want to free from inside out. So you're going to want to free max first, and then you're going to want to free your new user.